Oh, hey, the show started. It's great. That's my favorite Friday activity, just watching this show. Whoa, wait, hold on. It's me. Sorry. Hi, welcome to System Crafters Live. I'm David Wilson. This is the Friday stream where we get together as a community and talk about whatever topic I've come up with for the week, and this week is no exception. I'm just eating some popcorn here, okay? Summer is pressuring me to start the stream. I'm just trying to eat some popcorn here to have some sustenance before I start talking for 2 hours. Can I do that, please? Can I eat some popcorn and enjoy the show along with you? Would you stop screaming in the chat? I'm sorry if I just peeked the microphone. This is what this channel has turned into now, is what do you call those, the mukbang videos? You're just gonna see me eat like 3 bowls of popcorn and then lament the state of my life. I'm sorry for the glossiness here, but it is Athens in the summer. It's June, and it's like, 32 degrees every day so far. So, not so great. All right, let me see what people are saying in the chat here. I see some things. Summer's making Wayne's World references in the chat. Enrico in the YouTube side, Enrico says, great topic. I always wanted to review Gforth again. 1989 is long gone. Okay, let me say hello to people so far, all right? Let me say hello to the people so far, because there's a lot of people just jaw-jacking in here. Hello to Gun, Fearforest, Cal, Summer, Fade, Beach Al, Blinky Bob, Glenn. Let's see, who else do I see? I saw Judy and Ashraz joining. I saw Mike join. I think I saw Mike in the chat. I think Ashraz is here. If I didn't say Ashraz already, I think I just did say Ashraz. Like, step back a little bit, all right? Let me make mistakes. Jeff's here. Redacted. I see Fikri and Enrico over on the YouTube side. Hello, everyone. Hi to Zayman. Hello, folks, says Jeff. Are you like Smeagol now? Summer says Dave needs some AC. I just turned it on for the first time in like months. Ashras feels left. Dude, I just said hello to you twice. In a mood? What are you talking about? This Friday is what usually happens. Ashraz, you haven't been here, buddy. So I welcomed you 3 times now. Okay. We should start an AC for David Will Kickstarter. I have air conditioning. We're trying to turn it on because energy costs are so high. Energy costs are so high in Greece. I don't want to run an air conditioner unless I'm gonna die, which I might actually, because I'm not really built for this kind of heat. I should be, because I grew up in the southeastern United States, but I don't know, man. It's a little bit much for June, in my opinion. In my highly educated, well-founded opinion. Okay, so, hello, everyone. Nice to see you all. Sorry I wasn't here last week. I had some, family things to take care of. I'm being vague on purpose because why do you need to know? It's my life. You stay out of it, okay? Just kidding. I'm being a little bit punchy. Just trying to get it, start off right. Unfortunately, Marvin 2 is not in the System Crafters live chat, which actually would be pretty funny if he was, because we would all get to laugh at him live on stream. Marvin 2 is a bot, by the way, so just before you think I'm trying to make fun of an actual human being, no, we just make fun of a Markov chain bot in the normal System Crafters channel all day long. Yes, 89.6. So, yes, it's not that hot, really. I mean, it's hot if you live in Seattle, but it's not hot if you live in the Southeast. It's hot, but it's not like the hottest it gets. It's not the hottest it gets in Athens either, I'll tell you that. Cal says, regarding summer temperatures, if you fill your hat with water, you get a lot of evaporative cooling. Downside would be that the purple in your original deep purple hat that you bought at the concern would wash out. I like how deep you're getting into the lore of just that specific suggestion. Really nice. I mean, the blue-green of the System Crafters cog. Yes, it might do that. But what you really need is one of those like 10-gallon cowboy hats so that you can put actually 10 gallons of water in it, then just hold it over your head and let it pour all over your body to cool you off, right? Ashra says, let's just say you didn't need a pan for that popcorn. There's probably an insult in there somewhere. Redacted says, also your hat is full of water and your head is wet. That's true. Where's Trev? Excuse me, where's Treve? Somebody needs to go get Trev in here. I know I keep eating. The joke is over, but I'm still eating. This is the beginning of the end, folks. Whenever I start eating on stream, you know that things aren't going so well. I'm just kidding. Ashra says, I'm just saying you can go outside, throw some corn on the ground, and the asphalt is probably hot enough. It might be. That's true. It might be, indeed. Hello to DPX on the YouTube side. All right. Summer says, so there we are, 5 o'clock in the afternoon, and David Will wouldn't go on stage without a brandy glass full of brown M&Ms. What are we talking about? Is that the joke you were making? What was that coming from again? Wayne's World? I haven't seen that movie probably since it came out, which was a long time ago. Okay, so we got a cool topic today, a little bit different, but I like programming languages, so we're going to talk about some programming languages on the channel every now and then, but we'll get to that, all right? Ashra says, maybe it's time to go forth with the news. Maybe so. First thing I want to mention today in terms of news is that there's a new non-Guix substitute server proxy for IPv4. I may have mentioned this a couple weeks ago, but if you've been using the official non-Guix substitute server for Guix, which gives you pre-built packages for all the big stuff there, like the Linux kernel, the full Linux kernel, Firefox, other programs, recently, maybe a month ago, for some reason, they've turned off IPv4 access to the substitute server. So most people, I think, are not able to access a substitute server anymore unless you're able to route through IPv6. And for whatever reason, that affected me, partly because of home networking issues, but I think there's some other stuff going on too that's preventing it. So I've been kind of blocked from getting to that substitute server. So somebody out there created a proxy server that does give you access through IPv4, and it proxies the request across to the real substitute server for you through IPv6 so that you can get the substitutes that you need. I don't know who made this, but I saw it mentioned in the non-Guix channel on Libre chat, so thank you to whoever put this together. I haven't actually set it up to use it yet, but it seems like it will work. If you go to the actual site for it, it says the official substitution server for non-Guix. I think that's actually being proxied. So you're getting the response back from the actual server proxied through this server. So if you are bedeviled by the same problem that I have been, which I have been having trouble, not even just getting substitutes from the non-Guix server, it just times out. So every time you try to do like a Guix poll or any other Guix operation that has to request substitutes, it just like keeps polling and polling and polling, trying to get to the substitute server, and it can't find it because it can't route to it. So you either have to remove the substitute server from your configuration for non-Guix, or you have to switch to this one. Which means you have to do a system update. Well, okay, you don't have to do a system update necessarily. You probably can add the substitutes command line parameter or substitute URLs command line parameter in Guix to get past that. But at least in my configuration, I would probably have to do a system update first to update the substitute server for the channel, and then I would be able to pull things down. So yeah, that's kind of a weird thing to have to deal with, but at least someone stepped up to help out and to provide a solution to the community, which is great. Whoever knows who made excuse me, who made that proxy, let me know, because I would be happy to mention them, give them a shout out. Let's see. Summer says, you guys don't know hot until you've experienced where Gleneth lives. Yes, I don't want to go where Gleneth lives because I think I would probably melt. Mike says, oh, please say it's not the end, David Will. It's not the end. I'm just joking around. I like to, add a little bit of drama to the mix here. Eric says, it was 35 in Madrid 2 weeks ago. Yeah. It's about to be that temperature here soon, I think. Faye says, I could join the bot. I mean, we should probably try it at some point, but it could get out of hand real fast. I don't know if it shares the same memory with the things that we've been saying saying in the System Crafters channel. But that could be interesting. That could be real interesting. Maybe we should try it, Fade. I don't know. Left Pad says, where's Shelly? You mean Sherry. We haven't seen Sherry in a while. Yeah. Each channel has its own context. Oh, okay. Well, then, in that case, I don't know that it's going to be quite as entertaining. Sam says, oh, I'm glad it's not just me. Yeah, it's a thing that there's really no way to announce that there's an issue for this. You kind of have to go look into the problem and then find a closed issue on the non-Guix repository that says that they've shut off IPv4 access. Sam says this is a bit... No, Sam is in YouTube, Left Pad. Write a goof chat message. You know Sam's there. You copied his text. All right. I'm floundering. What are you talking about, Summer? I'm doing perfectly. This stream started off so great. What are you talking about? Beachhouse says it worked for me to specify the substitutes on the command line and update them in my config in one go. Nice. Okay, that would be good. If you can do that, then that would make it easier. So basically what Beachhouse is saying is put the updated substitute server. So let's just show you what I mean so that we are all on the same page here. I'm going to go to my dot files. I'm going to go to my base configuration. And if I go to the substitutes section here, add 9geek substitutes, I would have to change this substitute URL for substitutes.9geeks.org over to just this address that I'm putting into the show notes. Now, pay attention to the URL here. I didn't lose my voice. I've got popcorn kernels going in my throat. That's what's happening here. It's 9geeks-proxy.digital.xyz. It's not digital, it's digital, okay? So make sure you get that right. Put that in your config, and then whenever you run Guix system reconfigure on the command line, you also would have to specify the... I don't know what was open before. I think I still had OpenBSD running in here, apparently. Guix system, or actually Guix system help. There is the, where is it? Substitute URLs parameter. So you actually have to specify all of them, I think. The thing that sucks about that parameter is I think that you have to actually say what the other ones are, unless I'm wrong about that. But you would have to put that new substitute server URL into that command line parameter at the same time that you're trying to run the update of your configuration for setting the substitute server, or adding the substitute server, let's say. Is there a buzz? Let me see. Yeah, so do you still hear it right now? Because what I'm wondering is that if it's the air conditioner making that noise, or if it's whenever I touch the microphone in a certain way. It's less when I'm closer to the mic. Okay, it's probably the air conditioner making noise then. Maybe the noise gate's not set up right. Sorry for that. Okay. Mike says, since we're talking about Guix, does it run pretty well in a VM? I think it's fine. Sorry for the low buzz. Hopefully it gets better. It's not bad, it's okay. All right. Yeah, Beach House says, yeah, you have to put both Guix and non-Guix and any others that you want to use. That's the thing that sucks about it. Blinky says, this kind of represents the light headache of Guix. I love Guile and plan to fall in love with Guix in a few years when it settles down a bit. It's never going to settle down. Guix is a living system where things are always changing around, which not in a way that you constantly have to react to things, but it's a little bit, thank you, S-Copy. Check the power cord of the streaming laptop. I did plug that in this time. You know, it's a terrible thing whenever people in the chat have to actually remind me to do things that are so obvious, like plug in my laptop before starting the stream. Zaman says, can you try Temple OS one day? I don't know, maybe. Maybe. All right. Yes, Summer did ask me to look at Temple OS last week. It's a little bit too memey, I think. I'm reluctant Okay, yeah, that's a good point. Actually, as copy, floss regularly, especially after popcorn. I went to the dentist on was it Tuesday or Wednesday? Yeah, maybe it was yesterday, and got a cleaning. So if you get regular cleanings, what you realize is that after you get your teeth cleaned, everything just gets stuck in there again. So yeah, I'm gonna be flossing and brushing about 15 times after eating this popcorn. That's for sure. Christopher says, bootstrapping your own fourth stack in assembly first. That would be pretty awesome. I would love to do that, but I don't think we can do that in a stream. I'm not skilled enough for that. That's for sure. Okay, so let's get back to the news. I wanted to point out that our good friend Mike Dahlberg, who is D-Mirth in the chat here, let me know that recently he was able to give a presentation. He submitted a presentation to the PyCon conference. Yes, I know it's Python. We talk about Lisp and Scheme often in this channel, but I just want to point out something when somebody in the community I want to point out when somebody in the community does something cool. So Mike submitted a conference presentation proposal to PyCon and got to give his talk there about how he uses Python to manage his beekeeping. And when I say beekeeping, I mean literally beekeeping, and not just like, you know, some technology thing, which I thought it was whenever I first saw the title of the talk. Let me just pull that up real quick, because you'll see what I mean. It seems like we're talking about technology here, but actually we're literally talking about beekeeping, which actually makes it way more interesting to me. Detecting honeybee swarms using the integration of OpenCV, Pandas AI, and PyTorch. To me, that sounds like, you know, swarms, honeybee. Maybe there's just like some program called Honeybee that has a feature called Swarms. But no, this is actually literally about bees. If you watch the talk, Mike gives you a primer on keeping bees at the beginning, which I thought was really awesome. So you should check out this talk and tell Mike what you think about it, because I think he did a great job. So kudos to Mike for going to PyCon to give a talk about the stuff that he did for his beekeeping project. It's a pretty interesting work, for sure. So go check that out. I've got it in the show notes. I haven't actually committed the show notes yet, but you'll be able to click that whenever I post it after the stream's over. Peter says, I keep bees. I've been looking into those things too. I've got 4 hives and 2 apiaries. See, that sounds really awesome. But I don't think I would have the patience to do it. And I also know that my mother and her husband were also keeping bees at some point, and then they got loose and then got into her beekeeping suit and just stung her everywhere. So that kind of scared me off of the whole thing. I don't really think I would do that now. But I'm sure Mike is probably just out there, no beekeeper suit on, just kind of, you know, using Python code to control all of their minds somehow, maybe with radio waves. Who knows? Astro said, did Summer just release the bees? Is she breaking the stream again with too many emojis? Incredible buzz effect. So let's stop talking about that. I'm talking about bees now, and the stupid audio is buzzing. It's terrible. Look. Let me turn this thing off for a minute. I'm gonna start sweating profusely, but I want to verify that this is an issue with the air conditioner being on. Maybe keeping a Python close to the bees helps, says Judy. Yes. Peter says, yep, my wife experienced that, like 15 stings. I think my mom probably had more than that, and she's in her 70s, so I don't think that was a good thing. Redacted says, bugs in your code greater than bugs in your suit. Yeah, I would prefer that as well. I can deal with that much more easily. Can you clean the audio jack? There might be mustard on it. Or you think I'm just sitting here eating hot dogs all day or something? I mean, maybe I am, but you shouldn't judge me for doing that, okay? I'm in my office, sitting at my desk. I get to eat whatever I want. And if I happen to get mustard in the XLR audio jack of the microphone, that's my problem to deal with, okay? It's not yours, so leave me alone about that. Is it better now? Can you hear the buzz anymore? Because I turned the air conditioner off. I'm going to be sitting here sweating just so you can have pristine audio, okay? Is this what we all want? Is it what we're prepared for today? Blow into it like an NES cartridge? Yeah, then I'll get all my saliva in there and popcorn kernels, and it would get even worse. You can still hear it? Okay. Let me mute my mic before I start messing with this because I don't want to deafen anyone. Give me 1 second. Is that better? I think I may have not had it contacting well enough. All right. Thank you for letting me know. Apparently, it just wasn't connected all the way. You know, these cheap XLR cables that I bought from Amazon so long ago were not very good quality. Turns out that if you buy cheap cables, they're kind of cheaply made. Trev was right. He'll be insufferable for days. Yeah, it is actually true. It's true. Okay. All right. So today, I want to talk about the fourth programming language. Let me pull up the Wikipedia entry just to see. And we're getting guilted by Wikipedia at the same time, so let's just close that out. Fourth is a stack-oriented programming language and interactive integrated development environment. You can see now why maybe this channel would be interested in that. Designed by Charles Chuck Moore, first used by programmers in 1970. So, kind of like how Lisp is super old, Forth is also super old. It also has some very interesting features in its design, which we'll check out in a little bit. Although not an acronym, the language's name in its early years was often spelled as all capital letters, probably because file systems used all capital letters for things. So that's just what it was called, in all caps. This is another language that has a bunch of different implementations. There's a standard for the language, like a specification for the language, but there's many, many different implementations. Some are free and open source, some are proprietary. So it's kind of like Scheme in that regard, where there is kind of like a core design of the language, but then there are many implementations that have their own features or their own ideal use cases or platforms they run on, etc. So it's kind of interesting in that regard. It's another language where you could use it for a variety of different purposes, just depending on what implementation you choose. Forth typically combines a compiler with an integrated command shell where the user interacts via subroutines called words. So the symbols in the language that refer to functions or variables are called words, which kind of makes sense. And what you'll see when looking at the code is that the written text of the language actually kind of looks like just sentences, which is cool. So we will check that out in a bit too. Words can be defined, tested, redefined, and debugged without recompiling or restarting the whole program, which to us doesn't really sound so special because we do that all day long with Emacs Lisp or Common Lisp or Scheme or whatever. But back in 1970, that was pretty unique because usually you were having to write programs on punch cards and then put them into a computer. And you couldn't dynamically change the operation of the program at runtime. So kind of a new thing back in the 70s to be able to do interactive development, but this is very important for this language. Interactive development is a core feature, and it is part of the way that you're supposed to write and maintain programs with Forth. So it's very similar to what you would see with a Lisp. All syntactic elements, including variables, operators, and control flow, are defined as words, which means there's one way to define new syntax and features for the language, which also makes you think, do they have macros? And I think they do. So that's another way that's kind of similar to Lisp. So we'll have to continue looking into it to see how that works. But I haven't actually tried it myself, but maybe we'll try it here a little bit later. Let's see. A stack is used to pass parameters between words, leading to a reverse Polish notation style. This is one of the things that I thought was the most interesting about this language, is that usually in a programming language, you don't think in terms of the stack. I mean, maybe you think in terms of, and if you don't know what the stack is basically whenever you have, in most languages, the stack is whenever you are calling functions. You start off in a certain context in the program where you have sort of the current state of the registers that hold all of the parameters to the function that has been called, maybe some other state. for the local variables, maybe some stuff from the globals, whatever. Maybe the globals are somewhere else. But when you call another function from within that function, you're sort of pushing a new context onto the stack. So you keep pushing new things onto the stack as you call more functions, as that call stack gets deeper and deeper. You've probably heard of the term call stack before. The thing about the call stack is that you don't really have to think in terms of the stack. The compiler and the way that the language is implemented sort of take care of that for you. Not the case in Gforth. Actually, the stack is kind of like a core feature of how you interact with the language and the runtime, and it gives some really interesting effects. Now, I haven't really gotten too deep into this yet. I've only kind of played with the language a little bit this week, but I could pretty easily see how this gives you certain interesting language features kind of for free, which we'll see in a little bit. So I thought it was quite interesting that the language works like this. Also, if you've spent any time writing a stack-based interpreter or runtime, which I have because I did the mesh language, which is kind of a scheme-like language, but it is a stack-based VM. You'll be very comfortable here because it's basically the same thing. All arguments to the functions that get called get pushed onto the stack, and all return values from functions get pushed onto the stack as well. So you have to think about managing the stack as part of the code that you write. So it's kind of interesting. For much of Gforth's existence, the standard technique which was to compile to threaded code, which can be interpreted faster than bytecode. One of the early benefits of Gforth was size. An entire development environment could fit in memory on an 8-bit or similarly limited system. So another thing about Gforth is that I think it's pretty simple in the core language and easy to implement as a runtime. I've heard that many people will write a Gforth compiler or interpreter as kind of a toy project because the language specification is pretty easy, just based on the syntax alone and how the mechanics of the runtime are so obvious from the way that it works. It's an easy system to implement and then embed into a program, basically. No longer constrained by space, there are modern implementations that generate optimized machine code like other language compilers, so they could basically generate assembly on the fly, or actual machine code on the fly, and then run it. So JIT compilation of Gforth code in the more advanced implementations. Relative simplicity of creating a basic Gforth system has led to many personal and proprietary variants, such as the custom Gforth used to implement the best-selling 1986 video game Starflight from Electronic Arts. That's cool. Didn't know that. Gforth is used in the open firmware bootloader in spaceflight applications, such as the Philae spacecraft, and then other embedded systems which involve interaction with hardware. So it turns out that this is actually a pretty useful language on embedded systems. Because of the simplicity and also because of the debuggability of the system, which is cool. Sunny over on the YouTube side says, I love Gforth. Actually, I'm implementing one right now. Gforth is the most powerful language I know. It is pretty interesting. It reminds me a lot of Scheme in terms of it having very powerful fundamentals that allow you to implement a lot of things in the context of the language itself. Beginning in the early 1980s, Moore developed a series of microprocessors for executing compiled Gforth-like code. Sure. So there was some chip design that was meant to work right along with that. So anyway, all that is to say that Gforth is another old language that has similarities to Lisp, or all the Lisps that we've looked at so far on this channel. And it has interesting properties that I think that we should sort of take a look at and absorb, just to see how another language could be Lisp-like in a way, but be done differently. Just see what we can learn from it. So, like I said, I've only played with it a little bit this week. I don't really know a whole lot about the language, so we're going to take a more investigative approach to looking into what makes Gforth interesting. And to do that, we're going to use the book called Starting Gforth, which is quite old, I think. I don't exactly remember when this was written, but it's been around for a very long time, at least the 80s probably, maybe even late 70s, not sure. This is a book that's available on the Gforth website for you to read, either in PDF form or on the online version like we're looking at right now. So if you want to play around with Gforth and learn by going through this, you can go follow through this Starting Forth book. I've got the link in the show notes if anybody needs to look at that later. And then we will be using the Gforth implementation, which is obviously a GNU Forth implementation. I didn't know this existed, but when I started looking for Forth implementations, I found this one. So since it's in Guix, we'll be using it. Summer says, what makes Forth interesting is that David Will's talking about it. Okay, well, cool. Gunn says, writing a Forth compiler in Scheme, I would totally do that. Hey, Case, nice to see you. I would totally do that. Case says, Forth seems so cool. I keep looking at it and thinking about it. Yes, it's another one of those languages. All right, so we're going to look at Gforth. There's the manual for that. We don't necessarily need to look at the manual because we're going to go through starting Forth, but maybe we'll refer to it later in case. Should have called it Gforth. You should call yours Gforth. I think it would work out pretty well. I think Case is going to write a Forth implementation in Bash, and then he's going to use that to re-implement Bash. So we're just going to go back to a full circle bootstrapping of Bash through Gforth, or maybe it should be Borth or Borscht. Who knows? Case says, apparently let over lambda implements Forth in common Lisp at the end. That sounds awesome. I have let over lambda. I haven't actually read it all the way through. Case says, maybe I will. Dave says, I was thinking Gforth too. Hey, Dave. Dave says, Forth is a simple language to implement. Yes, I imagine it would be. Sonny says, if you want metaprogramming, Forth is your thing. You can modify the compiler in the source file, and then you're able to write compile time code. You can even make self-modifying code. Yes, I get that impression from Forth, is that it's quite powerful. Even though it looks very simple, it's very powerful. There's a lot of kind of similarities, I would say, to Lisp and to Scheme in Forth, even though it was developed independently. So it's cool to see another angle on similar ideas. Okay, so let me make sure I've got Gforth installed here so that we can do something with it. So I'm going to go back into my shell. Maybe I should just full screen that thing. So Guix shell, Gforth. I feel like I'm saying Gforce with a lisp. Maybe that's actually the right way to do that. Instead of writing Gforth, if you're going to write your implementation in a Lisp, you should call it Gforce. Does that joke work? No, it should be called Gforth, but spelled Gforce. Okay? We get that now? Everybody on the same page? Okay, anyway. So we're in Gforth. We're in the REPL. CMAC says, NVIDIA is coming for you. Can we sue NVIDIA? Forth is older. Yes, we can sue NVIDIA. We're going to have a class action lawsuit against NVIDIA to take the name back. All right, anyway. So type bye to exit. Bye. A Forth stream? Pog, okay. Gforth. I'm speaking Spanish, am I? You mean Spain Spanish? You mean Ibiza Spanish, okay? That's how it works. It's not just Spain Spanish, it's Ibiza Spanish. All right, anyway. So, fundamental Forth. What does the introduction have in here? I don't think we really want to see that. Just make fifth, says Judy. Yeah, that actually does work. FIFA says, Dave Gower made some pretty good content about Forth. Cool. Nice. All right. A living language. So this is a pretty interesting introductory example because what it does is give you an idea of what it's like to build up a program consisting of Forth words. I really actually should have the Gforth package installed in Guix. I'm kind of groaning to myself right now because I know this might not go well, but let's see if I can do that. So Emacs at SCM. Let's see. If I put... Come on. Load up. There's a package. I think the package must have the Emacs stuff in it. Yeah, it includes an editing mode for Emacs and an interpreter featuring completion and history. So if I put Gforth into my Guix, what was that in? It's in packages Forth. Okay, cool. So use module GNU packages Forth. Let's do it this way. I'm just gonna drop in Gforth right here. And then back over in the terminal, I'm going to update system. Anyway. Let's see if this works. Let me check the chat at the same time, because this may take a while. Who knows? I don't know if I've actually updated my channels since the last time I tried to reconfigure, so this could be all like a major problem. Why not Geek Shell? I already did it in Geek Shell, but I'm trying to get it pulled into Emacs. You know, alternatively, close the buffer. Thank you. Alternatively, let me check. GNU store Gforth. And we're going to go up in this folder, share, Emacs, site Lisp, right there. I want to grab this folder path. Would you stop? All right. So add to load path. Wait, load path. Is there not something in Emacs Lisp for that? Push. Load path. Put the path. Say what? Okay. Is it add to load path? It's not a interactive function. Add to list. Somebody remind me what I'm supposed to do here. Okay, got it. There it is. Okay, now let's see. Require Gforth. Guix autoload packages. Features. Who knows? Yes, that's definitely my password, left pad. Load path, load path. Guix is so user-friendly. I never said Guix is user-friendly. Who said that? Not me. Oh, no. All right. Now comes the time where I have to wonder how worth it this is before I keep trying to plug away at it. So, let's just get into it, okay? Let's not bother with that right now. We're just gonna go into the REPL and focus on playing with the stuff. Copy file content into the config. Hope there's no relative paths. Yikes. Rename your machine. Just breaking my machine for a 75-year-old programming language. I could probably run that in the background, though. How about I just try that again? I'll just let it run while we do the other things. Let's see if it actually does anything. Okay. So we're having an imaginary situation here. We're writing code to control a washing machine, a microprocessor-controlled washing machine programmed in Forth. Ultimate command is in your example is named washer. Here is the definition of washer as written in Forth. It starts with a colon. Can we read this? Starts with a colon, washer. Wash, spin, rinse, spin, semicolon. In Forth, the colon indicates the beginning of a new definition. So what we're doing here is defining a function or a procedure. Okay, they call it procedure. I like that because Scheme calls it procedure. So I'm a schemer. procedure is the correct word, in my opinion. We have washer being defined, and the series of expressions here is wash, spin, rinse, spin. So that's actually calling effectively 4 different procedures in a sequence. The remaining words, wash, spin, rinse, and spin, comprise the definition of the new procedure. Finally, the semicolon indicates the end of the definition. Each of the words comprising the definition of washer has already been defined. For example, let's look at our definition of rinse. Rinse is fill, agitate, drain. So it's calling out to other procedures the same way. Let's see. Each of these words has already been defined elsewhere in our washing machine application. If we assume the code has already been written, we have a definition for the fill procedure. Faucets open till full, faucets close. In this definition, we're referring to things, in this case being faucets, as well as actions, open and close. The word till full has been defined to create a delay loop, which does nothing but mark time until the water level switch has been deactivated. I don't think it has code for all that, but the idea is that you should be able to write an expression like this where you have a parameter to a procedure, faucets in this case, and you call the open procedure, which gets faucets as a parameter, and then till full somehow is turning this into a loop, waiting until that's done, and then you have faucets again being passed into close. So the redacted says, if Gforth could do my laundry, I'm sold. Yes, for sure. If we were to trace these definitions back, we would eventually find they are all defined in terms of a group of very useful commands that form the basis of all Gforth systems. And many of the commands are actually defined in the language itself. The ability to define a word in terms of other words is called extensibility. Okay, that's also called just writing functions. Blah, 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 blah. All right, and now we start to actually write some code. So here was where things start to get a little bit interesting, okay? We're going to go in the REPL. We're going to start writing some expressions. Here we're going to write 15 spaces, all right? Oh, it's almost done. Or is it done? It's running, okay. So 15 spaces. Do I need a semicolon? No. Press enter. It actually prints out 15 spaces. So spaces apparently is something that's built into the Gforth language, or at least the implementation that we're using that the book also uses. Or at least the procedures that the book is expecting to have are implemented in Gforth. So 15 spaces, it actually did put 15 spaces in here, and then it says okay, because that's what it writes when it finishes evaluating expression. Now, 42 emit is another procedure, 42 emit. What this does is it emits a character based on the ASCII character code, which in this case is an asterisk. So it printed out an asterisk. So far we're seeing, we told it 15 spaces. I want 15 spaces, and it gives you 15 spaces. 42 emit, we're saying we want to emit a character on the screen that corresponds to the ASCII character code of 42, and it does that. So you can already see that when you call a procedure, the parameters of the procedure come first, and then the procedure is able to operate on those parameters. There's no parentheses, there's nothing to sort of delineate the separation of procedure calls, which is kind of interesting. So now we could put more than one command on the same line. For example, 15 spaces, 42 emit, 42 emit. So if we do that, 15 spaces, 42 emit, 42 emit. It will write out 15 spaces and then 2 stars, because those are the character for 42, which is kind of interesting because that's 3 different function calls. How does it know that these are 3 function calls being called in sequence? Sunny Boy says, on what websites are you streaming? On Twitch and YouTube. So interesting. Why is it the case? I guess we'll find out in a minute. So you could basically string together however many procedure calls you want, and there's sort of a fundamental design feature of the language that enables you to do that. We'll get to in a minute. So after you have, so we're now going to write our own procedure called star that just calls out to 42 emit. So we say colon, which is how you do a definition, star. 42 emit, and we have to then finish it with a semicolon, but that semicolon needs a space before it, otherwise you'll get an error. So star 42 emit says okay, because now it's recorded that definition, and we can now say star. Now it puts out 1 star. We can also say star, 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 and it will write out 3 stars. So you can use star as a word to indicate, I want you to print out a star for me. And we're not calling it like a function. We're just writing a word out as part of an expression, which I think is kind of interesting. If you've tried to use language features to your advantage to make expressive APIs before, you probably can start to see how this might be interesting. All right. So another system-defined word is CR, which performs a carriage return. So if you type in CR, press enter, it gives you a line break. Now try CR star, CR star, CR star, and you'll see that we get 3 stars on different lines. So now we could basically just put whatever we want to make the output we want. So margin, we're going to define something called margin. We're going to say first we want a carriage return, then we want 30 spaces. Okay, so colon margin, CR 30 spaces, semicolon. You type out margin, and then it will make a new line with that 30 spaces of margin here. So then we can say margin star, margin star, margin star. And we get 3 lines where there's 30 spaces and then a star. So we're kind of like just we're making recipes here in a way. We are defining higher level procedures that can be used to make more expressive expressions that look like sentences in a way. And I think that they give some examples that make that more obvious here. Gunn says, starts to feel like a logo with all the graphics. Well, only because this is the easiest way to do it. 15 stars, says Case. I don't think it works like that. Yeah, it doesn't work like that. So, but it does get into something interesting like that. So let's keep moving, all right? All right, so we got margin. Now we can define something called blip, which is margin star, okay? So blip, margin star. Does all this make sense? Is this interesting so far? Now I'm gonna say blip. That gives us 1 line. We can say blip, blip, blip to get 3 lines of stars, right? Cool. Now we need to print a horizontal row of stars. So let's enter the following definition. We'll explain how it works in a later chapter. So we're gonna make a stars here, like Case is asking for, colon stars. And then that's gonna be 0 do star loop, and that's it, okay? So I'm gonna say 5 stars. Now it puts out 5 stars here. So what's happening here? Well, we haven't specified that stars takes a parameter, but somehow is taking a parameter. So here we have 0 do star loop. So what we're saying is 0 probably is the starting count for the loop, and we're saying do, and then we're having some expression inside of that, and then loop. And I think that's to go back to the start of where the do began. But how do we tell it where to stop? Well, I think what's happening here is that since we're putting 5 in front of stars at the beginning, the 5 is being added at the very beginning of this expression. So it's basically turning out to be 5 0 do star loop. Now, I don't really have, well, actually, let's look at the Gforth manual, loop. General loops. Let's see if we can find the information about the do loop. I don't want that. I don't see do. Counted loops. There we go, right there. There's a lot more syntax here than what's in the tutorial, that's for sure. What is Summer saying? Terminate this loop by pressing Control C. Anyway, this is interesting. They don't have just a basic crash course. What? Okay. Syntax. Yes, yes. That's right, Sunny Boy Alex. I'm getting to that. I think it's going to tell us that in a second too. Anyway, let's let it unfold here, okay? Summer says he didn't even notice. What did I not notice? You already gave me the answer. What's the answer? And where did Summer get that? Did Summer get that from somewhere else? Anyway, so keep in mind that this is a very old book, and some of the syntax here may be considered old for the purpose of being. Yeah, I can't spend time scrolling up. I see where you said the code, but I can't read all that now. There's so much in here. Gun says Gforth only runs on 8-bit machines. No. You're reading the manual? Well, that's great. Anywho, so let's see, 35 stars. Okay, so is it going to get to the whole stack thing in a minute? The dictionary, sure. The stack, okay. That's right. So there is a whole explanation. Let me just see if there's anything else worth looking at here. You kind of get the gist of it, at least in the basics here. So the stack is the important thing. Sure. We're gonna see now what this looks like. In Gforth, there's one central location where numbers are temporarily stored before being operated on, or any other value, really. That's called the stack. Numbers are pushed onto the stack, and then operations work on the numbers on the stack. So if you want to see how this actually looks in practice, we're going to go down and write 3, 4 plus. Now, I'm going to press enter here. It doesn't tell us anything because it doesn't actually print out the result of an evaluation by default. So it's not a typical REPL, or at least I think that's the case. It's not a typical REPL that will automatically print out the result value of an expression. So if you want it to do that, you have to use period at the end. So 3, 4 plus period. We said that the result is 7. So what's happening here? Well, what's happening is that you are actually, by evaluating this expression, you are putting values on the stack yourself. So 3 and 4, as you have them here, are being pushed onto the runtime stack, evaluation stack of the Gforth language. And then when you type in plus after that, that means that the plus procedure will have to pull or pop values off the stack to use them for the purpose of the operation that it wants to do. So in this case, the plus operator will pop 3 and 4 off the stack. Actually pops 4 first because 4 is the closest. It's at the top of the stack. Everything here gets pushed onto a stack. So if you imagine like a stack of plates, you put the first plate down, you put the next plate on top, you put the next plate on top. In this case, 3 is at the bottom, then 4 gets put on top. So 4 is the first one to get popped off. So 4 gets added to 3 using this plus operator here. And then the dot, actually what the dot does is it takes the result value of adding 3 to 4. How does it do that? Well, whenever you run the operator of plus with the values 3 and 4, when it finishes evaluating that operation, the plus sign operation, the procedure, the result value gets pushed back onto the stack for the next thing in the expression to be able to pick up that value and use it. Or it may not use it, but in this case, the dot does use it. It consumes that value from the stack, the value of 7. So 3 gets added to 4, and the result value of 7 gets pushed onto the stack, and then the dot will pull that value off the stack to then print it out onto the screen. So if we run that expression, it writes out 7 directly because that's what's actually being done. In fact, can I do this? 3, 4 plus CR dot. Yes, it works. So because CR doesn't actually consume a value off the stack, it just writes something out. The next expression can then, or the next word, let's say, can then pull that remaining value off the stack and then use it, okay? Summer says, yeah, you can reuse stack values. When you pop it off, it doesn't necessarily have to get used up. I think that's what I'm reading here. It's sort of, yeah. So it's very interesting because now you don't have to think about things in terms of return values from procedures necessarily. You can think more about managing the values on the stack and how subsequent calls to expressions will then consume the values of previous expressions that have gotten executed, and then their results having been put onto the stack. Really different way of looking at things, I think. Fade says this is like assembly programming. It is kind of like that. All right, let's look into how nested expressions work. So we're going to look at an example of, this is called postfix, by the way. Postfix format, because the operator comes at the end and not the beginning. Lisps are prefix, right? Because you have the operator at the very beginning of an expression all the time. You have the plus sign that comes before all the numbers that will be added up in an addition expression. And Gforth is the opposite. It's literally backwards in terms of how Lisp works. The operator comes at the end of the expression, which actually makes it easier in a way to write out complicated expressions because it's all on one line and sort of the values kind of flow from left to right in a weird way. Okay, so let's suppose we wanted a word that will always add the number 4 to whatever is on the stack. This is where things get a little bit interesting, in my opinion. So we're going to write something called for more. All right, we're going to go into the terminal, for-more, and we're going to say for plus semicolon. Okay, reverse Polish notation. Thank you to Arini. All right, so for more. If we say 3 for more, what do you think happens? Well, it doesn't write it out, but we can put the dot at the end and it will write out 7. And the reason why is because we, as the person writing this expression, have pushed 3 onto the stack, and then we call the for more procedure, which expects that there's already a number there, and then adds its own number to the addition expression, 4, and then plus. So we have created a procedure that is almost like a partially applied addition operation. So if you've ever heard of currying before or partial application, you kind of get that for free in Gforth, which is really interesting because this is another really useful tactic in functional programming languages for building up abstractions, because often you will have a generic type of function which can take a number of values and sometimes, or a number of parameters, and sometimes those parameters could also be other procedures that get called in the process of using that function. So like map, let's say. So whenever you use map in a functional language, you give it the lambda or the procedure you want it to execute for each item in a list that you also provide. So whenever you, if you want to make a procedure that kind of bakes in the use of a particular procedure for map, then you would either have to make a procedure that calls map the way that you want it to, or you could use something like partial application to do that in a language that supports partial application. Map is not a good example for that. Other procedures would probably be a better example, but the point is that partial application is a way to specialize the use of a more generic or generalized procedure for a specific use case that you have, and it's kind of like built in by default. Judy says that's a nice way of saying that David ignored chat. What did I ignore? Yes, I am ignoring. I'm trying to talk. Anyway, so I think that's kind of an interesting feature that just falls out of the design of the language right there. I'm kind of enchanted by the idea of a language where you're kind of working directly with the stack, and you can use that as part of what the assumptions you can make about how the code operates, and how you can design libraries that take great advantage of that, let's say. And listen, chat is ignoring David too. That's right, Redacted. I'm being ignored here. Everybody's just having their own nice little discussion here, and ignoring everything I'm saying. Anyway. All right, so next, keeping track of your stack. Fourth stack is described as last in, first out. You can see from the earlier illustration why this is so. The 3 was pushed onto the stack first, then the 4 pushed on top of it, etc., etc. You can use .s to see what's in your stack for debugging. That's great. Let's just quickly take a look at that. So 3.s or more. Can I do that? Yes. 7737. Yeah, we've got a lot of junk in the stack apparently. So .s 277. Okay. What can I use to consume the values? They haven't gotten to that yet. If I use dot, does it do it? Ooh. Yes, it does. Dot consumes what's on the stack. What if I give it dot when nothing's on the stack? Stack underflow. Okay, fine. Makes sense. Manganese says, this is just assembly with macros and no registers. Sort of. Kind of cool though, right? All right. Right, okay, so it does say here, remember that each dot removes one number from the stack and prints it. Got it. Judy says, I assume num is a link. That's what it looks like. Robin says, hey, Robin, reverse Polish and Polish infix is just unpolished or unpolished. I'm guessing that's a word joke. All right. So, they start to talk about now how you can communicate these stack effects. Summer says, if you're just adding sequential numbers, you could just use a do in plus loop. Okay, cool. Then you free up the stack. Thank you. We're just going through the tutorial, the way that it's supposed to be. Thank you, Ashraz, for the message on the side. All right. So, Gforth programmers conventionally use a special stack notation for their glossaries or tables of words. We're introducing the stack notation now so that you have it under your belt when you get to the next chapter. So, this is actually a comment, I think. Manganese says, didn't your channel have old F# tutorials? It still does. I do have functional programming background. I mean, Scheme is a functional language, right? Gun says, Hasilup is reverse Polish. Yes, it is. That's true. All right, so the basic form of stack effects is to have, in parentheses, the words that describe the parameters that are expected to be on the stack when the procedure is called, and then hyphen, hyphen, and then what gets put on the stack after the expression is evaluated. And I think the implication here being that multiple values could be added to the stack, not just one. Sort of like how that works in Scheme. But in Scheme, it's a lot more clumsy to deal with, in my opinion. The dash separates the things that should be on the stack before you execute the word from things that will be left there afterwards. Summer says, I know, so am I, but I'm also writing stuff in my head like you taught me. Did I teach you to write things in your head? I don't even do that. Okay, so, for example, here's the stack notation for the word dot. The notation is in as being something that it's going to take from the stack, and then it has nothing for the after section, saying that it doesn't actually add anything back to the stack, implying that it removes it entirely. Redacted is asking a very important question. Why is a guy in a hood blinding a waiter at a conveyor belt? That is a very great question. It's a very strange image. I don't know what's going on here. Maybe it's very Pac-Man inspired. Kind of feels like Pac-Man inspired. That's a better explanation than the other thing that's in my mind at the moment. All right. So let's see. For the plus operation, we have, in parentheses, n1, n2, dash, dash, sum. So we're saying there's a number, there's two numbers that are being pulled off the, oh, that's the executor, the executioner. Oh boy. Anyway, number one, number two come off the stack, and then we return a sum back to the stack. So it gives you a way to do like the function signature, but it's actually not used by the language. It's more just a conventional comment, I believe, to describe how the thing works. If I'm understanding it correctly, okay? So they say that there's a place where you put this. We saw some of that in the manual, I think. Yeah, so whenever you use colon and define the name of the word, you can put that stack effect comment, I guess you say, right after. And probably the compiler in a more sophisticated implementation can use that information for compilation. Yeah, Summer keeps just jumping ahead. Dude, calm down. Let me go through this in a procedural way, okay? You're just giving away all the good stuff before I get there. I'm just kidding. If you could show me what tutorial you're using, maybe I can go there too. It's cool that you're learning, though. It's a really interesting language. I think that it's a little bit fascinating and also not too hard to learn. Redacted is calling up the what's that movie called? The one with Tom Hanks? Look at me, I'm the streamer now. Anyway. So, chapter summary, fourth words, blah, blah, blah. Yes, yes, yes. Great. What's the next chapter? How to get results. Is that right? Fundamental fourth. All right, how to get results. So if I know F sharp, do I know Haskell too? No, I do not know Haskell. Captain Phillips, is that the name of the movie? Yeah. Summer says, I have never, ever contributed to a programming stream before. Well, now you have, which is great. At least you're not hacking the stream. You almost did. All right, so. Subtraction problem, simply type it in. Sure. They're going into the details about using integers versus using floating point numbers here. So you have to be specific, I think. Like, let's take a look real quick. So 24 divided dot gives you, well, yeah. What about 20.0? That's not right. Do you have to actually put 2 zeros at the end for it to recognize it? Is it because they're not both floats? All right, something ain't right. Is there a different word for dividing floating point numbers? D. Okay. That was kind of a red herring. Judy has a very good point. If GNU ever makes an F sharp compiler thing, I hope someone there is clever enough to make it G flat. Jorge says, there's a project for when the society collapses and people need to do computing from scavenged parts that is called Collapse OS. Gforth is the operating system and programming language. That would make sense, actually. Yes. F slash 20.04 F slash dot floating point stack underflow. I don't know. Case says Ed would actually be a great editor for Gforth. Yeah, that actually does make sense. All right, Gforth arithmetic definition style. Let's say we want to convert various measurements to inches. This is actually kind of interesting. So we can define yards to inches, which is 36 star. So if you have something in yards, you want to convert it to inches, you can easily do a conversion like that. So like 10 yards to inches is 360, okay? Feet to inches, 12 star. So 2 feet to inches is 24. That's awesome. If we always want our result to be in inches, we can define yards, feet, inches. And then we can use the phrase 10 yards, 2 feet, plus 9 inches, plus. So it kind of becomes like human language in a way. Because you're saying 10 yards and 2 feet, plus 9 inches, equals 393. Or 10 yards, plus 2 feet, plus 9 inches, right? But notice the word inches doesn't do anything except remind the human user what the 9 is for. If we really want to get fancy, we can add these 3 definitions: yard for yards, foot for feet, and inch for inches. So you can also say the one variant of those and have it still sound like human language, which is cute. Not necessary, but cute. Oh, okay. Is that right? Is that right? So 20.0, 4.0, F divided by, and then F dot. Still not right. That's kind of weird. It doesn't like it. All right, anyway, let's skip ahead a little bit. There's a special floating point stack. Vision operators. Oh, is this where we're gonna see the stuff about the floating points? A modulus. Stack maneuvers. The word swap is defined to switch the order of the top 2 stack items. Interesting. Define numbers on the floating point stack that don't exist. Peter says special FP stack does make sense because of floating point coprocessors at the time. Okay. Let's see. Let's see, Summer. This is the last one I'm trying. 2.0, 3.4 E, F plus, 10.0 E, F plus, F dot. Still doesn't work. Who knows? 2.0. Really? Is that it? They all need an E? 3.1 E, F plus, F dot. Thank you to Sunny Boy Alex. Apparently the E was necessary on all of them. Okay. That's okay, Summer. Come on. Jerry says, so weird seeing this, bringing back 40-year-old memories. What did Jerry say? I saw something earlier that he said. Jerry says, Forth was the first language I learned about. I didn't have a computer. I read the book. That's awesome. Minas Manzar says, cool, let's build a web server. That'll be difficult. Anyway, all right, cool. I'm not so interested in all this stuff. I want to see something more interesting. Drop. Final stack manipulation operator is on the list is drop. All it does is discard the top stack value. Okay. We'll see some good uses for drop later on. Non-destructive stack print. We've got the .s. That comes up here. Playing doubles. Reverses top 2 packs of numbers. Okay, these are all words that come in the language, it seems. If it's a programming language, it must have a web framework. Maybe. Scopy says, wonder whether to copy the chat messages if David reads them on the native platforms either way. I'm not so often. I'm usually seeing them in IRC first, just in case you're wondering. I appreciate the effort, Ashraz, as always. All right, so we have some special versions of things here. The prefix 2 indicates that these stack manipulation operators handle numbers in pairs. The letter D in the stack effects column stands for double. Double has a special significance that we will discuss when we talk about N and U. Two manipulators listed above are so straightforward, we won't even bore you with examples, okay? So far we've seen arithmetic operations, swapping values, duplicating the top stack item, which is cool. Copies to the second item to top. So you're kind of like taking the one before the top item and then copying it to put it on top. That must have some utility somewhere. But you can see that like these fundamental operations kind of imply that there are probably common things you have to do in the language where you would need to use these. So it's interesting to kind of look at them and imagine why you would need such a thing. And it's also interesting to look at the stack effects signatures and kind of see how they are reminiscent of the signatures in languages like Haskell or in even F#, because they sort of tell you a little bit more directly about what a given procedure does or a function does, I think. Sunny says, with Word, you can see all words that are already defined with Word, and you can use C with the word after it to see how Word is defined. Let's see. All right, anyway, so dot C, or plus C. Yeah, that's not gonna work either. CC. Ooh, CC. You can CC itself. Parse name, find name. If drop 13, throw, then name C. Okay. So do you know Haskell? No, I don't know Haskell. I have seen some Haskell. I don't know Haskell. All right, cool. That's that chapter. The editor, we might not really worry too much about that. Let's see. Another look at the dictionary. You can define the same word more than once in different ways, and only the most recent definition will be executed. So that's pretty common for people who have used REPL before. You can also use forget to forget the definition of a particular... Say what? Oh, wow. That's kind of weird. So whenever you update a definition, it actually stores the previous version of the definition. It sounds like that's how you can do overshadowing, but in a controlled way. Each word apparently has its own stack of values, which is weird. If you type in forget and the name of a word, it will roll it back to the previous definition of that word. Megan says, never mention Haskell. The chat will fill with Haskell. And also asks, have you done Pascal? I have not. Words to see all things. Let's see what happens when I type in words. Whoa. F-tuck. That's some funky looking stuff, but that's cool though. That's a lot. You can see our own definitions here at the top too, which is funny. Ooh, G flat. I think some of these are like registered things. Anyway. Leftpad says, I'm so glad that F-tuck has a T in there. Grev says simple language in quotation marks. It is simple. Look at it. It's great. The word forget looks up a given word in the dictionary and in effect removes it from the dictionary along with anything you may have defined since that word. Since that word? Searches starting from the back. It only removes the most recently defined versions of the word. So now when you type greet at the terminal, the interpreter finds the original greet. Forget is a good word to know. It helps you to weed out your dictionary so you don't overflow. Huh. Simple does not mean easy. Yes. That's right. All right. How Gforth uses the disk. Okay. Are we talking about I/O here? The list of blocks, someone's type the block number and the word list. So list lists a disk block. Load loads a disk block. Blocks are hardly used for source text storage anymore. Preferred way to handle source is in standard text files using the word include to load them. So you can use include to pull code in from existing files. Another thing that's interesting about this language is that it has concurrency built in. It's single-threaded concurrency. It's kind of like how it works in JavaScript or other languages where there's kind of an event loop in a sense, and you have lines of execution that can be paused, and so the other lines of execution, concurrent lines of execution, can be resumed and run until they also pause. So for things like IO operations, or even like explicitly with something that's equivalent to a yield. So you can do concurrent programming in Gforth. It's talking about multitasking impact here. I'm guessing that has something like that. Judy says, I assume the stacks are separate. Some of them are, I think. Yeah, I'm not sure what all this disk stuff is about. If someone can kind of tell me in the chat why that's useful, that'd be cool, but I haven't really looked into that. Uh-oh. Sorry. My screen got locked. Okay, fine. The editor and staff. Why are we talking about disk blocks in a chapter called that? Decisions. Okay, conditional statements. Cool. That's a good thing to know. 12 equal. If fill carton, then. Test whether the number on the stack is equal to 12, and if it is, the word fill carton is executed. If not, execution moves right along to the words that follow then. Okay, that's cool. Oh, that part doesn't apply anymore with load and list? Okay. Bella Knox on Twitch is getting in trouble from Ashraz. Let's see. All right. Cool. So we're defining full, question mark full. Ooh, they use predicate style stuff as well. Question mark full, 12 if. Then we put a literal string in, it's full, then semicolon. So you jump to the end. Interesting they have variables, yeah. All right, 11 full, okay. 12 full, it's full, okay. All right, cool. An if-then statement must be contained within a definition. You can't just enter these words in calculator style. So apparently they cannot be used directly in the REPL, which is interesting. I guess because you need to have the context of a procedure necessary to do a jump to a later expression. Who knows? Don't be misled by traditional English meanings of the words if and then. These words that follow if are executed if the condition is true. Yes, it's because of the reverse order of things. The words that follow then are always executed, as though you were telling the computer after you make the choice, then continue with the rest of the definition. So that's a very important difference from other programming languages. It's not if else, it's if then. And after if is a thing that gets executed if the expression evaluates it true. And then what comes after then always gets executed, no matter what. That's very different. You could easily get tripped up on that, I think. There is no else in this example, right? Maybe there is an else, though. Who knows? Sunnyboy Alex says, if is a word that executes in compile time. That's cool. All right, so, how, though? How is it possible? Jorge says, Sun Microsystems had servers where the bootloader was in Forth. Yeah, I don't doubt that at all. Partial list of comparison operators you can use before an if-then statement. Okay, so it's just the general Boolean checks. Another word, invert, doesn't test any value at all. It simply reverses whatever condition was just tested. Okay. So does this like result in a Boolean value? Is that what happens? So you have 220 greater, which is an expression that gets evaluated to a value. And then if, it just looks to see if the thing on top of the stack is a true, whatever is equivalent to a true. Actually, let's just check that out. 3, 4 greater than, 3, 4 greater than dot. 0, okay. 4, 3 greater than dot is, negative 1. What? 3, 3 greater than dot. Did I do something wrong? Four is greater than 3. Yes. 3 is greater than 3. Negative 1. C-style Boolean. Simon says, Lisp is not weird. Yeah, I had to make a catchy title, though. Come on. What are Booleans in Forth? Apparently, is 0 or negative 1 in this case. Zero or non-zero. Okay, interesting. Is 0 true? That's weird. Fate says, man, I agree. Provide an alternative phrase in an if statement with the word else. I can't read all the chat and the tutorial at the same time, Summer. Come on. There is an else. Okay, I see it now. Thank you. All right, if looks good. Else, no way. Then 0 is false and every other value is true. Cool. Thank you to Sunny Boy Alex. So that's kind of like JavaScript, isn't it? Is 0 false in JavaScript? Can't remember. I know I asked about else. Anyway, how does it work? Because it's interesting that there's if, and then the expression to be executed, and then else. Huh. So imagining this, how would it actually work in practice? If looks at the value on top of the stack to see if it's positive or negative, how would it control the execution of the next thing? It must be something like a macro. But if that doesn't work, it moves on to the next expression, which is else, which probably also looks at the value on top of the stack at the inverted version of it, and then checks that, and then executes this instead. I'm guessing. Or does if return something? Does it put something back on the stack to say that the condition didn't pass? Who knows? Nested if-then statements. That sounds awful. All right. So we've got a series of expressions. Duplicate 18 less than if. Is it using duplicate so that it can consume that value for the expression but still leave it there on the stack for the next one that comes through? That's where these things start to become useful. There are fundamental operations that are given to you to help you to implement certain types of behavior, like having multiple logic expressions in a row. So you need to call duplicate first to put whatever's on top of the stack, whatever's represented by this n, put another copy of it on the stack so that the future operations can then consume that and then do whatever's necessary for the whole remaining expression. And then once we get through this expression, we're back to the place where n is the value. The original n is the one that's on the stack again. So we duplicate it again and then run everything again. That's what I think I'm seeing here. Sunny Boy says, you have two stacks. You have the return stack and the parameter stack. The parameter stack is the one that you push stuff usually on. The return stack is used by if and do. Oh, okay. That's interesting. Didn't know that was a separate thing. I've heard it was separate, but now it makes sense. Gforth on GitHub. Nornagon. I haven't heard that name in a while. Ooh, literate x86 assembly implementation of Forth. That's kind of awesome, actually. Look for Jonesforth.s. It's like annotated code here. Wow. That's crazy. I love this. That's just like some light afternoon reading. Let's go put that in the show notes. I just heard a click noise. I don't know what that was. It's a tutorial on how Forth works. Love that. I think Summer is giving me grief for reading other people's comments and not hers. I'm not trying to ignore you, Summer. I just see things every now and then. The left pad is clicking the switch to turn me off and to replace me with a replicant. See, look, I didn't even see Robin's comment from above. Robin says, that doesn't Forth have syntactic words like dot quotation mark that can consume input at read time, kind of like CL reader macro functions? Yes, it does. I haven't looked at it yet, though. All right. So you're not the only one whose comments I don't see sometimes there. Summer. Peter says, Day Ivy will. Ashra says, sorry, Summer, I can't read this chat at the moment. I'm preoccupied with just copying the others. Oh, you say that. I thought you were talking about me reading the other ones instead of hers. All right. Back to the tutorial. I mean, we're making progress here. What time is it? Okay, we got about 25 minutes left. Closer look at if. Oh, there's a false. False is 0. True is -1. Okay, that makes sense. You're not copying, Summer. Ashraz is copying. That's what scopy is. Okay, so false invert, true invert. If we'll take any non-zero value to mean true. That makes sense. Prove it. Try entering this test. Sure, sure, sure. Yeah, we're getting deeper into some of the examples here. I think this is good stuff to read through. If somebody wants to get a better sense of the language, why are we apologizing? Okay, there's no need to apologize. So definitely read through this stuff if you're interested to learn more about how to structure expressions. Also, there's multiple lines here, it seems. Okay. Philosophy of words, problems. All right, let's go to the next one. Philosophy of fixed point. I apologize to everyone. Everyone, I'm sorry, okay? I'm sorry that I'm conditionally reading messages. Whatever catches my eye whenever I look over briefly is what you're getting. All right, this is where we're getting into floating point operations, it seems. Or they call it fixed point. I'm not so interested in looking at this right now. But just so you know, it's there. You're spouting out more code than I've ever seen you write in 4 years. I've seen you write Emacs Lisp. Throw it for a loop. So looping. Uh-oh. For a moment, YouTube told me that it's not getting data, which is total BS. Okay, throw it for a loop. I don't really care too much about this either. We can take a look really quick, but yeah, so 10 is the maximum number, 0 is the starting value. Do I dot loop? Sunny Boy Alex says you have to write 200 lines of assembly, and the rest of the implementation can be written in Gforth itself. That is pretty awesome, actually. Big Edie says I'm a big time influencer now. No way he can catch all the comments on the stream. Yeah, I'm trying too hard to read things at the same time. But yeah, the design of the language is very amenable to like having assembly written for it, because it's almost so much like a Turing machine, right? Because you've got like the tape, and you do operations on the values on the tape or something. Is that the right way to describe that? All right. Nested loops. It appears to be possible. Judy says, except the tape has limited movement compared to Turing. Yes, you're right about that. Not as much random access. Okay, if you want to control the step size, you can use plus loop. Let's see. All right. Indefinite loops, there's basically a begin until, like a while loop. How do you get out? Oh, you got like a variable that you can use to check the value. Until. Okay. So why am I skipping over all the looping stuff? Mainly because you can go look at it yourself. I kind of want to see something really interesting. So we definitely want to look at extending the compiler. Excuse me, extending the compiler. First of all, under the hood, what's that? Inside interpret. picks words out of the input stream and tries to find their definitions in the dictionary. If it finds a word, interpret has it executed. And now the cows claim that this is the executioner has been made obvious to the fact that it has an axe in his hand. Thank you, Sunny Boy Alex, for joining the IRC and for your help so far. Thanks, Carswell. So, yeah, you can do it yourself if you want to. Vectored execution. Structure of a dictionary entry. Okay, cool. I like the fact that it goes through this information. I don't think it's really useful to us right now, but it's interesting to know that it's there in case you're interested in what Gforth does and want to see how it works. User dictionary. The dictionary will grow into higher memory as you add your own definitions. So it's got like a whole memory model, it seems, that it's describing here, which is cool. Yeah, the precompiled Gforth, system variables, load definitions, user dictionary. Wait, what? Ah, yeah. Okay. And this is the part that expands. There's some padding in here. There's a parameter stack. Okay, so you could basically have a point where you squeeze your memory, where your dictionary reaches where your parameter stack is. There's also the return stack separately, user variables, and then buffers. Okay. What did you say, Summer? And where? So you have to be careful then about your memory usage in that way. Parameter stack. So yeah, let's see what is different about the return stack. The return stack operates identically to that of the parameter stack. There are no high-level Gforth words analogous to SO and SP referring to the return stack. 60-second delay. I wonder if that's a YouTube thing. I think Restream is doing it. I think that's why I got a warning from YouTube about the data rate. I think that Restream is not providing YouTube with the stream data fast enough. It's happened before. It gets really off track. All right, let's skip that. Worth looking at, but not right now. IO and U. Let's see what the IO looks like. Okay, there's emit. We saw that before. Outputting strings from disk. The word block copy is given block into an available buffer and leaves the address of the buffer on the stack. Is this like legit anymore? Should we even be looking at that? String operators. Block is useless now, says Sunny Boy. Okay. What is Summer saying about variables? All right, so let's skip that. I want to see the compiler part. That seems interesting. Extending the compiler. Okay. In comparison with conventional languages, Gforth's compiler is completely backwards. Okay. Let's see. Peter says there should be a display of the NTP synced clock in the corner to geek out on latency. Oh boy. Then people will be complaining even more about the latency all the time, I think. Okay, let's see. Traditional compilers are huge programs designed to translate any foreseeable legal combination of available operators into machine language. In Gforth, however, most of the work of compilation is done by a single definition, only a few lines long. It's Special structures like conditionals and loops are not compiled by the compiler, but by the words being compiled. Special structures, not compiled by the compiler, but by the words being compiled. So macros are kind of at the very foundation of everything, it sounds like. Lest you scoff at Gforth's simple ways, notice that Gforth is unique among languages in the ease with which you can extend the compiler. Finding new specialized compilers is as easy as defining any other word, as you will soon see. You've got an extensible compiler, you've got a very powerful language. Yes, macros. Let's see. Yeah, runtime versus compile time. That's interesting. See you, Summer. Thanks for contributing all of your hacking knowledge here. Different kind of hacking. So, we've used the term runtime when referring to things that occur when the word is executed, and compile time when referring to things that happen when the word is compiled. So far, so good. But confusing when a single word has both a runtime and a compile time behavior, which is very common for macros in languages, even in newer languages like Zig that does have a comp time concept. A defining word is a word which, when executed, compiles a new definition. A defining word specifies the compile time and runtime behavior for each member of the family of words that it defines. Using the word constant as an example, when we say 80 constant margin, we are executing the compile time behavior of constant. That is, constant is compiling a new constant type dictionary entry called margin and storing the value 80 into its parameter field. But when we say margin, we are executing the runtime behavior of constant. That is, constant is pushing the value 80 onto the stack. We'll pursue defining words further in the next few sections, okay? The other type of word which possesses dual behavior is the compiling word. A compiling word is a word that we use inside a colon definition that actually does something during compilation of that word. One such example is the word dot quotation mark, which at compile time compiles a text string into the dictionary entry with a count in front, and at runtime types it. See if here for us. Other examples are control structure like words like if and loop, which have compile time behaviors distinct from the runtime behaviors. We'll explore compiling words after we've discussed defining words, okay? So each of these words is to create a definition. So create and colon and some of the constants and variables. And how are these defining words defined? First, we'll answer this question metaphorically. The definition of a defining word must specify two things: the compile time behavior and the runtime behavior for that type of word. Create. A compile time, create takes a name from the input stream and creates a dictionary heading for it. At runtime, create pushes the body address of example onto the stack. Example. What happens if we use create inside of a definition? For example, the definition of the variable, we are indirectly using create to create a dictionary head with the name oranges in an xt that points to create's runtime code. What? How do we specify different runtime behavior in a defining word? By using the word does angle bracket as shown here. You can delineate the compile time operations from the runtime operations, apparently. Creating a dictionary entry compiles the value for the constant from the stack into the constant's parameter field, okay? Marks the end of the compile time behavior, and at fetches the contents of the constant using the body address that will be on the stack at runtime, okay? So defining words you can define yourself. Let's eliminate the count by creating a defining word called characters whose product definitions will leave the address and count on the stack when executed. So if we say 20 characters me, we'll create an array called me with 20 characters available for the character string. When we execute me, we get the address of the array and the count on the stack. Now we can write pad me move instead of pad me 20 move. Okay, so basically we're kind of baking in the length of the array into the symbol that gets created from this. That's cool. Create duplicate, comma, a lot. Yeah, I'm not absorbing this right at the moment. Let me see how far this goes. So characters. Characters calls into create at compile time, create dupe. And dupe is takes the value 20, it duplicates the value 20 that's already on the stack, on the parameter stack. And it copies it into the first cell of the array. And then allots an additional 20 bytes beyond the count of the string. Interesting. Okay, and then the does part of this does a runtime behavior, which is, and it also has the stack effects signature, duplicate, cell plus, advances the address to point past the count to the start of the character string, swap at. Chat silent at the moment. Yes, because I'm staring at the screen, mouth agape, trying to understand what's going on here. All right. Yeah, I'm not really absorbing this at the moment. I think that I would have to be a little bit more experienced writing expressions for this. Yes, you really should play with it to get a feel for that. You're right, I should. I think the examples they're using is... the examples that they're using are not as obvious to me, like how they would be useful. So maybe that's why it's harder for me to kind of understand what's going on. So compiling words are words used inside colon definition to do something at compile time. So it's basically the words that are used for control structures and things like that. Colon compiler ordinarily looks up each word of a source definition and compiles each word's address into dictionary entry, but a colon compiler does not compile the address of a compiling word. It executes it. So I think that's why they were saying that things like if don't work in normal expressions in the REPL, because it has to be done inside of a colon expression. So colon expressions are special because they have their own extensibility points for turning code into other code, let's say. Peter says, is there a fourth game jam? That's a great question, because I would love to participate in a fourth game jam. There must be one somewhere. And if there's not, maybe we should make one. But it does actually, it sounds fun. Also, in fourth implementations, there's usually a C foreign function interface. So you could use something like raylib. So you could actually do real full-on graphics programming, game programming with that if you wanted to. C function, yeah, calling C, there's a C interface in Gforth. I don't know if this actually, let's see. I don't know if it's necessary to compile C code to make this work. Oh, it does have openlib and libsim and call C. Yeah, so you can actually load stuff out of C libraries and call it directly from within Gforth if you wanted to. Trev says, did we look at anything notable written in Gforth yet? I haven't looked to see if there actually is one. But it sounds pretty cool, though, to try to do a game jam using raylib and Gforth. All right. Manganese says, there are maybe like 4 people in the world who knows Forth well enough to write a game on it. Well, you know, I think that a game is a good way to force yourself to figure out how to use the language effectively for something like that. Like, it's a non-trivial exercise, so I think it'd be pretty fun to do that. We're not here defining words. Ooh, like things after the semicolon, you can say immediate. Fourth harmonics, yes, exactly. Oscar says, it's time to restart Flux Harmonic, but in fourth? No, 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 no. I can't do that. Don't have time for that. I wish. So you'd be the 5th guy who knows fourth well enough, maybe. Anyway. Maybe that's something to look into for another time. Peter says, there is a P4th Radelib library. That's cool. Sunny Boy says, it's funny because Jaya tries to get metaprogramming into game dev, but Forth would be more powerful. Yeah, I think, DSC Mech. I don't know, like, is the way that Forth is designed amenable to game development? Like, could you write performant game code using Forth? I think it's possible for certain types of games, not for everything. But I would certainly be interested to try it. Oh, wow. So Soding did Forth in Python. That's cool. Forth can be as fast as C, says Sunnyboy Alex. I can imagine so if you're using things correctly. Okay, so conclusions. Forth clearly is a very interesting language. It has some different ideas on how to do a lot of the same things we've seen in languages like Lisp and Scheme, where you have a dynamically okay, let me find a better way to phrase that. A dynamic environment for the development and debugging of code, and also the ability to do metaprogramming using something like macros. It's basically macros that they have in language, but also with a very interesting way of dealing with how procedures are called using the sort of the stack model that's in the language. So I find it very fascinating. I don't think necessarily that it's a practical language that, you know, many people could start using to do development of applications, but you could probably say the same thing about Scheme, and I've done plenty of practical programming with Scheme, so who knows. But it's certainly interesting to look into if you are a fan of programming languages, especially weird old programming languages that have useful characteristics that are unlike what you normally see. Blinky Bob says, as I mentioned earlier, if you want to get a handle on Forth, pick or write a simple VM and implement Forth for it. The problem with coming from a higher language to Forth is that people tend to overthink it. Yeah. And so, just like Sunny Boy Alex says, I agree with Blinky Bob. I think that that's right. It's like, you have to really kind of get into the mental model of how Forth works, maybe to really understand it well enough to use it effectively. And writing your own VM and compiler for it, or at least interpreter for it, would probably be a good way to do that because it is so straightforward. Also, I keep hearing about this thing called Factor, which is another language that's kind of derived from Forth. Is it not? Factor. Yeah, influenced by Forth and Lisp. I haven't looked at all at this, but I mean, obviously the syntax looks a lot like Forth, right? There's a website, I think, that looks kind of nice, which is what matters the most whenever you're looking at programming languages, is whether the website looks cool or not, right? Judy says, so next stream, M4. I don't know about that. W says, has Factor been mentioned? Yes, just now. Does the website not work? What's going on? Anyway. So, yes, like I was saying, Forth is cool. You should look into it if you're interested in these kinds of things. I'll probably play with it some more just because of my own curiosity. But I'm going to try very hard not to trick myself into writing a Forth interpreter or compiler, because as I found with Mesh, that's a rabbit hole. And you can get stuck in rabbit holes for a while It's probably not a good thing if you tend to get stuck in those types of rabbit holes. So I hope you all enjoyed the stream, and let me know in the comments what you think about Gforth and about whatever else that happened today, like me eating popcorn at the beginning of the stream. Sorry about that. Just thought it would be funny. And I hope you all have a great weekend. Thanks for your time and attention. Until next time, happy hacking. See ya.